All right, let's talk about some special parallelograms. There are three types of special parallelograms, and we're going to sketch each of them. A rhombus is a parallelogram with four congruent sides. So I'm going to do my best, kind of typical rhombus drawing. Now they can look different, my goodness. Well, let me see if I can actually draw a rhombus without making my lines completely wavery. There, okay. So we've got a rhombus, all four sides congruent. Okay, and it's a parallelogram, so opposite sides are also parallel. All right. Rectangle is a parallelogram with four right angles. Most people are very familiar with a rectangle. Okay, but the definition there, four right angles. Once again, a parallelogram, so opposite sides are parallel. So when we say in a definition that it's a parallelogram, that brings all the properties that we've talked about parallelograms to that as well. Opposite sides parallel, and diagonals bisecting each other, opposite sides congruent, opposite angles congruent. Then a square is a parallelogram with four congruent sides and four right angles, so kind of a combination of the previous two. So square, okay, four congruent sides, four right angles. All right. And once again, it's a parallelogram. So we have those parallel sides. All right. So now kind of using that, what we're going to do is we're going to put together a Venn diagram where we're going to group all these things together. So the first thing I'm going to do is I'm looking at this, I want to go ahead and classify these four items, squares, rhombuses, rectangles, and parallelograms in there. And their relationships here, when you were looking at their properties. So if we think about first kind of the outside, the mat area, the rectangular area out here that the two ovals are sitting in, the all-encompassing area, that's where you would have two sets of parallel sides. Okay? That's the only rule for that area, and that is just the run-of-the-mill parallelogram. Doesn't have to be any special parallelogram. Just has to have two sets of parallel sides. Now, if we get more specific and we go, okay, we want to have all right angles in this oval here. Okay, well, the one that has just all right angles, and that's the only rule on it besides it being, it includes it's a parallelogram, is the rectangle. Okay, rectangle has all right angles. And then if we want to get more specific over in this oval, we could say, well, all sides congruent. Okay, and that then takes into account the rhombus. Now when we put together the rectangle and rhombus, kind of join the two, where we'd actually have all right angles and all sides congruent, we then have the square. So the square is the most specific type of parallelogram that we have there. Okay, so just kind of another way of looking at it. And kind of completing these statements, a quadrilateral is a rhombus if and only if, well, if and only if all sides are congruent. And a quadrilateral is a rectangle if and only if there are four right angles. And then finally, a quadrilateral is a square if and only if, well, you could say if and only if it has all sides congruent and four right angles, or you could say if and only if it is a rhombus and a rectangle. All right, so hopefully that gives a decent idea of how those three special parallelograms relate. Let's go ahead and we're going to draw some pictures here to help us determine whether some statements are always true, never true, or sometimes true. So for any square ABCD, angle A is congruent to angle B. I have ABCD here. All right, kind of fix up that side there. And it's a square. And so if I go ahead, A, B, C, and D, okay, we have 4 right angles there, all sides congruent. It says angle A is congruent to angle B. Well, angle A and angle B are congruent. In fact, since it's a square, they will always be congruent, okay? So this is always, because all angles of a square, man, I'm having a hard time writing there, measure 90 degrees. It's always true. Okay, let's take a look at another one here. For any rhombus, okay, well, let's go ahead and draw a rhombus. Now, we know that rhombuses can look different, but let's go ahead and draw the run-of-the-mill rhombus there, okay? So for any rhombus, W, X, Y, Z, WX is perpendicular. So WX is perpendicular to XY. Well, that does not appear to be true right there, okay? The question is, in a rhombus, is there ever a chance that they're perpendicular? And so it's not always, but yeah, there is a rhombus, a special rhombus we just dealt with in the previous problem, WXYZ, where that could be true, right? If we have a rhombus with 4 right angles, also known as a square, then it is true. WX is perpendicular to XY. Okay, they intersect at a right angle right there. Therefore, since those two are perpendicular here but not here, this is sometimes true. It's sometimes true, we'll say only if the rhombus is a square. That'd be a good explanation there. All right, and let's try one more here. So, for any rectangle, okay, well, we know a rectangle can look a couple different ways. It can look like that, where you have opposite sides not congruent. Okay, but it also could be where you have opposite sides congruent, or excuse me, where you don't have all 4 sides congruent, but it could also be a square, right? So let's go ahead and label this Q, R, S, and T. And it says QS, all right, well, QS, that's here, bisects RT. Well, that means that would be the congruent to that, and that congruent to that. Well, remember, a rectangle is also a parallelogram. Okay, and a parallelogram always has angles that bisect each other. So, or excuse me, have diagonals always bisect each other in a parallelogram. All right. So the answer is, and I said it in there, always. All right. So don't forget that these shapes are also parallelograms. Okay, let's go ahead and move on to some theorems here. The rhombus diagonal theorem. The rhombus diagonal theorem says a parallelogram is a rhombus if and only if it's, let's try not to switch slides, diagonals are perpendicular. Okay, so I have these diagonals, right? Oops, let's go ahead and draw a diagonal that looks like a diagonal. I have a diagonal there. I have a diagonal there. Diagonals of all rhombi are all rhombuses there are perpendicular. A rhombus opposite angle theorem says a parallelogram is a rhombus if and only if each, well, diagonal bisects a pair of opposite angles. Now let's make sure we understand what's happening here. Remember, in a rhombus, all sides are congruent, all right? Oops. Okay, and we also know that opposite angles are congruent because it's a parallelogram. Okay, so when I look at that, and I start just thinking of diagonals, I'm going to erase the congruent markings on the sides here just for a minute. And I start looking at the diagonals. That diagonal right there bisects this angle, which means it cuts it in half. It also bisects this angle and cuts it in half, which means that that angle right there is congruent to that one. But since the big angle, we'll call that angle A, was already congruent to angle C, that would mean the bisected angle, those parts are also congruent to each other. So we now have 4 angles that are equal in measure. Okay? And if we call this B and we'll call this one D, the same thing happens there. This diagonal bisects angle B and D, and it cuts those in half. Okay? So angle D breaks into 2 equal angles, and angle B breaks into 2 equal angles, and those angles inside are congruent. So if I were to call this point M, I would know that DMC, or excuse me, CDM is congruent to DMA. My goodness, I keep messing that up there. CDM is congruent to ADM, and those are also congruent to ABM and congruent to CBM. So all 4 of these angles are congruent. We could do the same thing with the others. I'm not going to go through that process right now. But you've created a set of 4 congruent angles there. Okay, and the rectangle diagonals theorem says a parallelogram is a rectangle if and only if its diagonals are congruent. Okay, so that would mean if I have this rectangle here, and we go ahead and draw in these diagonals, maybe a little better picture of the diagonal there. Those diagonals, if we call this A, B, C, and D, we would say that AC is congruent to BD. Okay? And so if you want to finish your notes off up here, let me go ahead and write those out. I know I said I wasn't going to spend the time doing it, but we'll do it real quick. DAM, yikes, okay, is congruent to MAB or BAM, okay, which is congruent to DCM, which is congruent to CMD or CMB. All right. Very good. So applying those now, finding the measures of the numbered angles here. So if we look at this, we see that this is a rhombus. All sides are congruent. Okay. So angle 1 and 2 we also know are equal to each other, as well as 3 and 4. All 4 of those angles are equal to each other. That's kind of what we just talked about right here, right? 4 congruent pieces. So that means if this is 73 and it's a parallelogram, opposite angles are congruent, that is 73. So out of 360 total degrees in a quadrilateral, we've taken up 2 sets of 73. Okay? And so 360 minus 273s is 360 minus 146, which is a grand total, and we'll just call this X here, okay, which is a grand total of, man, that was anticlimactic. Okay, grand total of 214. Okay, which means that angle 3 and angle 4 and angle 1 and 2 make 214. So if we have to take that 214 and divide it up evenly, right? If we call that angle A and angle B, okay? Well, A plus B makes up that 214. So we have to divide it up evenly. So that means each one of those is 107 degrees. So angle A is 107 degrees, and angle B is 107 degrees, which means we now have a grand total of 360 degrees in our quadrilateral. Okay? Well, angle B was bisected and angle A was bisected, and we know that the measure of angle 1 is going to be equal to the measure of angle 2, which is going to be equal to the measure of angle 3, which is going to be equal to the measure of angle 4, because they're all the same measurement. We're going to have, well, you could either do 214 divided by 4 or 107 divided by 2. That would give you the measure of those two, okay, which is a grand total of 53.5 degrees each. Each one of those measures 53.5. All right. Now looking at our next shape here, we do have a rhombus, and remember diagonals in a rhombus, they intersect at right angles. So automatically we look at angle 2 equals 90 degrees. The measure of angle 3 equals 90 degrees. Now there's a couple ways we can figure these other ones out, but what I notice right away is I have a triangle right here, right? Okay. This triangle right here, any triangle adds up to 180. So I know that 52 degrees plus 90 degrees, which is angle 2, plus the measure of angle 1 has to equal 180. Okay? Well, that means 52 and 90, 142, plus the measure of angle 1 equals 180. It means the measure of angle 1 is equal to 38 degrees. And if angle 1 is 38, remember, still a rhombus, that bisects. Okay, these two angles are congruent. This angle gets bisected by a diagonal, and the opposite angle is also bisected, and those angles are congruent to both of these. So 1 is congruent to 4. Measure of angle 1 equals or is congruent to measure of angle 4. Therefore, angle 1 we know is 38 degrees, so angle 4 is 38 degrees as well. Okay. Well, I think we got two more slides here. Let's see. Can we classify a shape as a rectangle? Explain. Well, 44 and 44, 23 and 23, well, I definitely classify it as a parallelogram. Opposite sides are congruent. In order for it to be a rectangle, I'd have to see right angle markings, which I don't. Okay, so no, I can't. Let's try to get back to that slide there. No. There are not right angle markings. Okay, or we don't know if there are any right angles. All right, well, let's move on to another rectangle. Rectangle QRST. I'm going to draw a picture before I even know what's going on here. So Q, R, S, and T, and I know it's a rectangle. Okay, well QS, okay, well, let's switch up our colors here for a minute. QS and RT. Okay, well QS is 3y plus 25. All right, and RT, maybe a little more complex, but 5y minus 11. So I kind of have that. Now I know that that's kind of a mess, way of drawing it, but what I do know are diagonals are congruent here. So I know that 5y minus 11 is going to be equal to 3y plus 25. Okay, so I move that 3y over, we get 2y minus 11 is equal to 25. And I don't know how well this will show up, so I'm going to outline that there. Okay, we'll add 11 over, so 2y is equal to 36. So 1y is 18. All right, we found y, but we didn't find the length of diagonals. So to find the lengths, I actually have to plug that 18 back in, or substitute back in. So I know that QS is 3y plus 25. That is the diagonal QS. And so if I plug in the 18, or substitute in the 18, I get 54 plus 25. And 54 plus 25 is 79. Okay, so the length of the diagonals are 79. And I could also plug it into 5y minus 11. You get 5 times 18, or 90 minus 11, which is 79. Okay. Hey, one last piece, and it's identifying a parallelogram in a coordinate plane. We need to classify ABCD with those vertices in as many ways as possible. Okay? Well, let's go ahead and plot the points first. All right, so we got 3, 7. And there's A, negative 2, 3, negative 2, negative 3, excuse me, B, 8, negative 7, C, and 13, and 3, D. All right, so if I'm connecting those, whoa, that last line went off target there. Try that again. Okay. All right, ABCD. Well, at least I know right away it's a quadrilateral. It has 4 sides. So we can say it's a quadrilateral. All right, so we have one thing we can call it. Other ideas? Well, we've studied parallelograms, so maybe it's a parallelogram. It could be, looks like maybe a square. Maybe a rectangle. Maybe a rhombus. Okay, well, let's start with parallelogram. If it's a parallelogram, let's recall, a parallelogram would mean you have parallel sides. So if I look at the slope, okay, let's go ahead and check out the slope here. Slope is what I rise and run. And since I have the points, I'm going to go ahead and take a look at that. I'm going to show the picture, rise and run, and then I'm actually going to calculate it using algebra, and I'll show why here in a minute. But let's go. I rise from B, which is at negative 2, and then I run to A, which is at, negative 2, 3, and then run to A, which is 3, 7. So slope, go ahead and write it right here, slope. Calculating slope, I know that the measure of, or the slope of AB is equal to 7 minus negative 3 over 3 minus negative 2. Okay. Now, it might be important for me to actually list the slope formula just for those who don't recall it. The slope formula is y2 minus y1 over x2 minus x1. Okay? So, key piece of information there, right? And so if I do the calculation here, I end up with 10 over 5. Remember, 2 negatives mean add, so it's 7 plus 3, which is 10. 3 plus 2, which is 5. And I know I could simplify that, but I'm not going to for a specific reason here. Okay? And so I want to know if, and by the way, the whole reason I drew this is 10, rise 10, run 5. Okay? So you could draw the triangles in there, but I'm actually doing the calculation for a reason. Okay? So the measure of, or excuse me, I keep saying measure, but the slope of CD. Okay? Well, CD, I'm going to look at my y values and subtract them. So I have negative 7 minus 3. Okay, and I have 8 minus 13, which also is, in this case, negative 10 over negative 5. And notice negative 10 over negative 5 is the same as 10 over 5. These are both become positive because you're negative divided by negative, right? Okay, so this is same slope. So that means AB is parallel to CD. All right, very good. So we have some parallel lines there and there. Okay, well, we can go through the same process with AD. All right, find the slope of AD. Well, AD, I'm going to just go through them fairly fast. 7 minus 3 and 3 minus 13. Notice I'm just taking my y's. Okay, 7 minus 3 and then 3 minus 13. Okay, and so I get 4 over negative 10. And then the slope of BC, again, B, so I have negative 3 minus negative 7 over negative 2 minus 8. And that gives me a grand total of 4 over negative 10. Again, hey, same slopes. So AD is parallel to BC. All right, so we know we also now have a parallelogram. Very good. Well, the question is, do we have a rectangle or square? So do we have any right angles? Well, if you recall, if you have perpendicular lines, I'm going to write it up here. Have slopes that are inverse reciprocals. Okay, in other words, you would flip the slope. So for instance, my slopes here, I have 10/5 and 4 and negative 10. I would flip it, right? Or numerator becomes denominator, denominator becomes numerator, so it would be 5/10 and change it to negative. Well, and it should equal this. Well, 5/10 is not 4/10. One's positive, one's negative, but we have 4/10 and not 5/10. Therefore, these are not right angles. We do not have right angles. Our lines AB and AD, AB and AD are not inverse reciprocals, so they do not intersect at right angles. So you cannot have a square or a rectangle because you don't have right angles. The last one is to see if the lines are equal, the sides are equal in length, to find out if it's a rhombus. And you'll note, in order to find out length, you have to use the distance formula or the Pythagorean theorem. And distance formula is derived from the Pythagorean theorem. Okay, it'd be nice if I spell formula right. All right, and I'm just going to point out here what the distance formula is. D is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Hear my dogs barking downstairs there. Okay, and what I want to point out here, and the reason I didn't simplify up above, is because if you've already done the slope formula, okay, I did not mean to do that. See if I can, there we go. Let's go to my highlighter here. Okay, you've already done the slope formula. There's y2 minus y1. So if I'm trying to find the distance, let's say I'm trying to find the distance. I really don't want to use that color. Try this again. Trying to find the distance from A to B. Okay? And that would be this whole formula here using x2 minus x1 squared plus y2 minus y1 squared. Now, I'm not going to have to do much here, and I'll show you why, because you've already done the work. Okay? You did the work when you looked at it here. y2 minus y1, that was this part of AB. And you came up with 10. Okay? So you'll know if alright. So you'll know if I were to write that over here, this would become the square root of 10 squared plus, okay, that's what x2 minus x1 was. Oops, excuse me, that would be the y part. show that there. The y2 minus y1. Okay, that would be my 10 squared. And then the x2 minus x1 you also did. Find a different highlighter here. That would be that part, right? And that's our bottom. That's the 5. It goes there. So we've already done that math. So with that, we can actually say, well, that is 5 squared. Okay, and I now know that is the square root of, well, 25 plus 10, well, 25 plus 100, or 125. That is the distance there. Okay. So if I kind of clean this up a bit so I can actually fit what I need to, distance of AB. Alright, and I'm going to do the same thing just really quick to find, I know that the opposite sides are going to be congruent because it's a parallelogram, but I need to know if AB is congruent to, say, AD. Okay, so I'm going to find the distance of, and let's switch colors here real quick. We'll go to, let's say, green. Distance of AD. Okay, and once again, you've already done this. You've done it right here. AD, here's your x, x2 minus x1, so negative 10 squared, plus, and then y2 minus y1 is right here. That's your 4 squared. All right, well, that gives me 100 plus 16, or the root of 116. These are not equal. Therefore, those distances are not equal. They're very close, but they're not equal. Therefore, this is not a rhombus. Okay, the classification that we can use, the two ways we can classify this is a quadrilateral and a parallelogram. All right. Well, I think that's all I got for you. Double check here. Yep, good luck.